Okay, we're going to look at section 4.6 in Math 31, and we're looking, this section talks about complex fractions. It'll be a two-part video. I'm breaking it up into two sections. Okay, a complex fraction is a fraction, and maybe another fraction inside a bigger fraction. So you've got the center fraction bar, and then in the numerator or the denominator, or in this case both, you've got another fraction. Now, one way to handle this isn't the way I'm going to be doing it on most of these problems, is to interpret this middle fraction bar here as a division. So that would look like this: 7/15 divided by 14/15, and then we simply take the division algorithm that we learned earlier. You change it into a multiplication by the reciprocal of the second fraction, upside down version here. And the 15s cancel here. Cross canceling is okay once you turn it into a multiplication problem. And we'll simplify this result by dividing by 7. So you get an answer of 1/2. Now that way works. It's not as versatile as the other way I'm going to show you. So this is probably the way you want to do it on most of the problems here. I'm going to erase that and start over again. What you're going to do here is take the approach that you can multiply the top of a fraction and the bottom of the fraction by any number you want, as long as you do it top and bottom. So we're going to multiply this top and this bottom by some specific number. And the number you want is the one that will cancel both the 15s. So the common multiple of 15 and 15 is actually just 15. So multiply by 15 here and by 15 here. And we can cancel those, and we can cancel those, and you get 7/14, which then becomes 1/2 when you divide by 7 and divide by 7. Oops, sorry, 14 divided by 7 is 2. Okay, here's another example, and we're trying to get rid of a 3 and a 5. The number that will cancel those both is the multiple of 5 that's also a multiple of 3, in other words, 15. So it's the same one we had last time, but that's just a coincidence. Okay, here we go. Multiply this by 15 and the other one by 15. So what we have here is 15 times 2m over 3. You want to do the dividing first. 15 divided by 3 is 5. 5 times 2m is 10m. And on the bottom here, you have 15 divided by 5 would be 3. And times 4 would be 12. And then we'll divide the 10 and the 12 by 2. So when you're done simplifying, you get 5m over 6. Okay, example C, you can see that we have a lot of fractions involved. There's 4 of them. We're subtracting 2 fractions on the top and adding 2 fractions on the bottom. Now you're going to look at these denominators here, 2, 4, and 6. Now there is another 2, but that doesn't change what we're going to do here. You need a number that cancels with 2, cancels with 4, and cancels with 6. And the first number that these all go into is 12. 2 goes into 12, in other words, 2 is a factor of 12. 4 is also a factor of 12, and so is 6. So we're going to multiply this by 12. Now, because of this minus and this plus here, we're going to have to use the distributive property. In other words, you're going to multiply by 12 times both fractions up there. The first time around, 12 divided by 2 is 6. 6 times 5 is 30. And then the second round here, 12 divided by 4 is 3. 3 times 3 is 9. Now you could multiply first. 12 times 3, 36. 36 divided by 4 is still 9. But it's usually easier if you'll divide first. So now on the bottom here, you got half of 12. And then we'll do this part here. 12 divided by 6 is 2. 2 times 5 is 10. Simplifying the top gives 21 and the bottom gives 16. And there are no common factors in 21 and 16, so we can't simplify that any further. And we are done with part C. Okay, on this next one here, we have a denominator of 5 and another one of 10x. And there's actually a 1 down there, but we'll ignore that. So 5 and 10x, 5 and 10 both go into 10. And then we have to add the x on there to be able to cancel with that one too. So we're going to multiply top and bottom by 10x. And there is a plus sign here, so you have to distribute on both sides of it. The first round here is 10x divided by 5. That would be 2x. 2x times 3 is 6x. Okay, now let's figure out what we get on the back half here. 10x times 2. And then in the lower half here, the 10x just cancels off, and you get 3. So we got like terms up top. That's 26x over 3. Okay, in example E, we have both a multiplication and a subtraction. And you have to do, the order of operations comes into play here. You have to do the multiplying first. So what we get on the first part here is, well, within that multiplication there, you can cancel right here. And don't do that if that were an addition between them. You end up with 1 times 1 is 1 and a 10 down there, and now minus 1/3. So we're subtracting fractions here, and we need a common denominator. 10 and 3 both go into 30, so we're going to make this a 30 down below by doing this. And we end up with 3/30 minus 10/30. So we got our common denominator of 30 there, and that'll get negative 7/30. The order of operations came into play. We did the multiplication first, and then we did the subtraction. Okay, this one is another example where you have to use order of operations. And we would normally say dividing and multiplying are the same priority, but when they're on the same line like this, and that's all you got, you have to go from left to right. So we're actually going to do the division first, and then we'll concentrate on the multiplication. So this part of the problem we'll just copy for the first step here. Okay, this would be 5/6 times the reciprocal of 1/3. And now we're going to copy the back half here. So that gives, let's see, 15. Actually, we can do some, at this point, we can do a bunch of cross canceling. So let's do that. Divide by 3 and divide by 3. Divide by 5 and divide by 5. And then we can even do this. Divide by 2 and divide by 2. So now we're left with 1 times 1 times 2. And on the bottom, 1 times 1 times 3. Okay. Next, we've got exponents mixed with an addition, and the exponents have to be done first. So let's see, 2 times 2 times 2 would be 8. And then down here you got 3/4 times 3/4, which is 9/16. Now we have to add these, and they don't have a common denominator. You got a 1 down there, but we can easily make that a 16th down there by doing this. So I'm going to take off to the side and go 16 times 8 be 48. And then 8 times 1 plus 4 more is 12. You get 128. 128 over 16 plus 9 over 16 gives 137 over 16, and that's all we can do on that problem. Okay, here the addition has to be done first because of the parentheses. Then we'll take care of the dividing by 7/9 at the back. Now, it's convenient here. You can see that we've got a common denominator there, so I'm just going to put those together right away. It won't be hard to do. Okay, so negative 1/3 plus, sorry, negative 4/3 plus 1/3 is negative 3/3. And we're going to copy the rest of the problem. Now, we'll take care of that in a second here. But, yeah, let's go ahead and leave this one like it is. And we'll change this to multiplying by 7 over 9. 9 over 7. So I took the reciprocal and changed it to multiplication. That's the way we handle division. Now that it's a multiplication, we can do some cross-canceling here. Divide these by 3. And your final answer is staring you right in the face here. It's going to be negative 9. That's what you get when you multiply across the top. And then 1 times 7 on the bottom. So you got your answer, negative 9/7. Okay, so we'll pick up the next video with the continuation of this section.